Welcome to our last section of inequalities and our last section of chapter 1. What we're going to be looking at is other types of inequalities that we might want to solve. These ones are fairly similar to what we were doing last time. They just got a little bit of extra steps. I'm kind of combining the two sections together. Here is our procedure for solving polynomial inequalities. If you want to pause me for a sec while you write that down. I don't know if you use those fun shots or not. Anyway, so that's what we need to do in order to be able to solve these inequalities. So here is our thing. So we want to first get this thing equal to 0. So that's what it's talking about by getting it into standard form. So minus x is greater than 0. And we want to factor this polynomial. So whoop, whoop, whoop. So we get an x minus 4 and x plus 3. Now we can identify the zeros of that polynomial. The zeros of that polynomial are going to tell us is going to tell us the places that we need to check on our graph. They're going to kind of take our number line and divvy it up into pieces. So we've got our first part right here at -3. And then we've got another part over here at 4. And I don't really care about the spacing, and I actually really don't care about writing much of anything else. What I want to do after that is I want to do test points. So I need some number between each one of these sets, some number in each one of these sets. So some number between -3 and 4. I know an easy one. It's 0. I'm going to test 0 in that area. Over here, I want some number that's bigger than 4. So how about I try 5? I could use 10 if I wanted to. I could use 20. It just needs to be bigger than 4. I don't want to actually use 4 because that's right on my boundary line. It's not going to give me good information. I'm also going to use -5 just because then it'll be kind of similar computations and it'll just be easier for me to figure out. But you could use a different number if you wanted. I could have used -10 over here and 5 over there. Now I got to write a lot, so I'm going to get real close to it. Yeah, real close. All right. I want to put these into my equation, my original equation, that x squared minus x is greater than 12. I zoomed in too much, so now I don't know for sure. Greater than 12, good. Okay, so I want to replace that x with a 0 and see if the statement comes out true or not. So is 0 squared minus 0, is that bigger than 12? Well, is 0 bigger than 12? No. So this is a bad place to be. My inequality doesn't work here. If I tried over here with that -5 on my inequality, I would do -5 square this minus -5. I want to know if that's bigger than 12. Well, let's see. I get 25 plus 5. Is that bigger than 12? Yeah. 30 is way bigger than 12. So this is a good place to be. So I want to put some line here. All of those numbers are going to work. Remember, with test points, if one number works, then everybody works. If one number doesn't work, nobody's going to work. 5 squared. Oh, Mel likes that idea. She meowed about it. Checking over here, we've got 5 squared. That's 25 minus 5. Is that bigger than 12? Yeah, 20 is bigger than 12. So this area works. So I do have graph everywhere over there. I'm going to zoom back out so I can see the full thing. That's fit, I think. All right. Now I have to put either parentheses or brackets on that thing. How am I ever to decide? Well, I just check right here. Whatever that is, that's what everybody's getting. So that one would be a parentheses, so everybody gets parentheses. Our final step is to write this in interval notation. Read it like a book. -infinity to -3, union 4 to infinity. Whoop. Done. Let's do one more. All right. Now this one seems like it's going to be a little bit trickier, but it's not. So once again, I am going to get this thing equal to 0. So I got x squared minus 4 less than or equal to 0. I'm going to factor this one. You could technically do like a square root to solve. I don't recommend it. Plus, I'd rather just do them all the same way. And I told you to factor all of these, so I'm going to factor all these. So the two spots that I have to check are 2 and -2. I'm going to space out my number line a little bit better. That last one was a little tight. So I've got -2. I've got 2. I need some test points. So I'm going to use 0 again because I'm lazy and that's easy. I'm going to use -3 and 3. Again, those could be different numbers, but it's just easier to use the same number. So why don't I? And I might be able to do this one from a distance. So x squared is less than or equal to 4. So is 0 squared less than or equal to 4? Yeah, that's totally true. So this middle piece is good. I need to check the other pieces too, though. Let's see, -3. If I square you, are you going to be less than or equal to 4? Well, you get 9. That is not less than or equal to 4. So no worky, no graphy. So let's try over here. 3 squared, are you less than or equal to 4? Well, I get 9 again. I said before that's no good. Since that doesn't work, then that whole area doesn't work. Now, what am I to do for the ends? Check that guy. It'll help us out. Bracket, bracket. To write this thing in interval notation, read it from left to right. -2, comma, 2. Both of those had brackets on them, so I put a bracket on both. All right. Next, there are going to be ones that look a little bit more complicated, but they're even easier. Oh, sorry, these are on your PDF notes. Since you get imaginaries, you can't graph them on the number line, so you don't have anywhere to check, so everybody works. And I think there's one more that's a PDF note, another PDF note one. Gross decimals would use better numbers. All right, rational inequalities are going to follow the same rules, except before we were only checking restrictions on the domain in the denominator. Now we're checking denominator and numerator. We want to look in both spots for zeros, and that is going to determine all the places that we've got to check. Which means we'll have to check a lot of places, but that's okay. We're big kids. So if I'm looking at this thing, first thing I want to do is factor it. So I get x plus 2, x minus 2 in the denominator, and x minus 3 in the numerator. So the spots I need to check, my zeros are x equals, let's see, we got -2, we got 2, and we've got 3. But we also need to remember that domain restrictions. X still, even though we're dealing with an inequality, it cannot equal plus or minus 2. Those are bad places to be, and we still don't want to be there. So let's see, I want to divide this thing into thirds. I'm not going to space them out nicely. I want to space them out nicely so I have enough space to do my work. They're not going to be evenly spaced though. So let's see, our smallest number is -2, and then we got 2, and then we got a 3. My drawing is not to scale, and I still did not give myself enough space to draw, so I'm just gonna, no. I'm gonna do this trick, watch this trick, it's so good. It's the best trick ever. Look, now I have more space. All right, so I need a test point for each one of these spots. So between -2 and 2, I know a good one, 0 is gonna work. I'm gonna use -3 over here. I need some number bigger than 3. 5 sounds pretty good. And now this is gonna be the tricky spot. I need a number between 2 and 3, so I'm gonna use 2.5 for that one. So I'll do that to kind of divvy up my work. So I need to check each of these. So is -3 minus 3, not x, squared minus 4. I want to check if that is greater than or equal to 0. So in the numerator, we get negative 6 over 9 minus 4, so that's 5. That's a negative number. Negatives aren't bigger than 0, so this is no good. That area is no good. Dang it. All right. What about the other one? Let's see 0. So 0 minus 3, and then 0 squared minus 4. Are you bigger than 0? Well, then we get negative 3 over negative 4 greater than or equal to 0. Oh, 3/4. Oh boy, 3/4. You're greater than or equal to 0. So it is okay to be between negative 2 and 2. 2.5. Let's see. We got 2.5 minus 3 over 2.5 squared minus 4. I want to check if you're greater than or equal to 0. So let's see. That is negative 0.5 over, let's see, 2.5 squared is 6.25 minus 4. So we get 2.25. That's a negative number. That's no good. Can't be there. All right, last one we got to check is 5. Come here. Come here. Need more space. Thank you. All right, so 5 minus 3 over 5 squared minus 4. Are you greater than or equal to 0? Well, let's see. That's 2 over 25 minus 4 is 21. Hey, that's positive. That's a nice positive thing. So that one works. So we can have graph over there. Now, what are we going to put on these things? Equal to. So we go equal to, and then we're about to go, we would normally put brackets on here, but look back at this. This said, no, 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 not in my house. Not in my house are you going to bring in that plus or minus 2. So parentheses on those two. Normally they would get brackets, but we still can't put bad things in the denominator, so we're going to put parentheses on there. So we got negative 2 and 2, parentheses. We got a gap, so we put a U, bracket 3, 2, infinity, close parentheses. There's our solution graphed in interval notation. And I believe that's it. Yep, yeah, there's some homework. That's probably wrong. Don't look at that. So thanks for watching, and I'll see you in class. Bye-bye.